So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, solar and battery storage systems have components from a lot of different manufacturers. It's not just like one box that gets delivered to your house and you plug it in. There's probably 50 different solar panel manufacturers that are active in the U.S., half a dozen companies that make inverters and electronics, and a dozen racking companies, and right now I count 3 major battery companies. Plus, there's 3,000 different utilities in 18,000 different cities around the country. Essentially, all these jurisdictions and all these different components make it very tricky to put a system together. Components need to be selected and connected properly. That takes engineering, which is a key part of every residential and commercial solar system. So every system that's installed properly goes through an engineering and permitting process. Doing this engineering work properly, quickly, and affordably is one of the keys to a successful solar installation business. So in this week's show, we're talking about solar and battery engineering. And my special guest is Josh Weiner, president of SepiSolar. Now, SepiSolar provides engineering services to solar and battery storage contractors. Josh and I go back to 2006 when he started working with me at Akina Solar as manager of design and engineering. So welcome to the show, Josh.
Thanks for having me, Barry.
All right, it's great that you're here. So why don't you tell our listeners a little bit about the services that SepiSolar provides?
Sure. Well, we're a turnkey solar storage and microgrid design and engineering firm. So, I mean, we do everything from layouts and structural analysis, electrical analysis, interconnection details, pretty much everything you need to get a project from concept to installation and commissioning and placed in service. So we don't install, we don't buy or sell systems, we don't buy or sell hardware. We're just designers and engineers with very specific specialized subject matter expertise. And then that's the project engineering part. We also do a lot of heavy technical consulting. And so I love how these two services play off of each other, because I think to be the best project engineer possible, you need to know what's best in class, state of the art, what's coming up in terms of technology, regulations, and programs. And likewise, I think project engineers inform consultants to be better consultants when they know it actually works and doesn't work on the ground floor. So it's really the consulting and the project engineering that we do.
So who are your typical customers? Give me a profile of those customers.
Yeah, they come from all different walks of life. I mean, it's interesting. I keep learning about who are our customers on a regular basis. But so EPCs, developers, owner operators, asset managers. But one thing I do notice that everybody has in common is they're looking for one or multiple of 3 things. Requirements. They want to understand what are the rules and regulations that govern these types of systems, of which there are many, and they evolve and change over time. Risk, they're looking for risk management or cost control. You know, they just need to know what their costs are going to be and to know that that's going to be protected through the long haul, whether they're an EPC looking at the next 6 months or whether they're an owner developer looking at the total cost of ownership. And then finally, design optimization, just value-added engineering, getting good designs with good efficiency, with good product.
Okay, so how is you started doing solar engineering, over a dozen years ago. How has the solar engineering and the battery storage engineering changed over the past dozen years?
A better question is, how does it not change? It's ever a moving target like the rest of the industry. For example, the old saying used to be, like anybody with a truck can install solar. And maybe that's a new saying. I don't know. Mm-hmm. I'm noticing anybody with a CAD license can design solar. The difference is, though, of doing it, what that means is that anybody can play. What it also means is that you have a huge spread in things like quality, customer service, and also the design engineering aspect. Sometimes drafting, design, engineering all gets kind of mixed together. But, putting lines on paper is one thing. Actually getting good designs out into the world is another. For example, we do a lot of rescue missions at SepiSolar. And so we have customers who come to us who say, I got these plans from somebody, Joe Schmo in a basement or Joe Blow around the street, and we're having problems. And so, the wire sizing might have been done right. The conduit sizing might have been done right. Overcurrent protection, voltage drop, all looks good. But this inverter is twice as big as it really needed to be. And it's causing problems with interconnection and maybe a dozen other things. And if you just kind of solve the root cause problem, use an appropriately sized component, we saved that customer $1,500 at the snap of a finger. That was maybe easy for us, but very difficult, obviously, for him and his previous designer.
Yeah, the big change that I've noticed, and we've taken advantage of it at Cinnamon Energy Systems, is it used to be that the solar contractor had to do the engineering him or herself. Right. It was in-house. And heck, you remember back at Akeena and Westinghouse, we had a room full of like 60 engineers and project managers. It was extremely inefficient and expensive. But I found that it was expedient to outsource the engineering to qualified firms. And there's also firms to which you can outsource that are not as qualified or might not do as good a job. You get the plans back, you say, this wire doesn't look like it's connected in the right place, or the overcurrent protection isn't right, or where's the ground wire? So that's changed, but the outsourcing has been a terrific boon in terms of reducing our total costs, because we don't need to maintain that stable of engineers to handle our variable workload.
Yeah, I've found a lot of contractors, EPCs, developers, they have a core competency. They have something they do really well. They originate deals, or they have access to money in project finance, or they're great installers and they've got the great trucks and equipment and so on. So what I found, the outsourcing model that you just described, is just it just fits really naturally with all kinds of organizations that have a core competency and just need those close, tight partners close to them to build out additional capabilities that they need to be successful. And so we want to build out those design engineering capabilities because they touch so many processes of the project development overall process.
Yeah. The EPC or the contractor has to have a basic idea what's involved, but you really leave it up to the qualified engineer to work out all the details.
Yeah. And when you're outsourced too, you're not tied to any one particular developer's or EPC's pipeline. You see, a lot of EPCs and developers, rightfully so, standardize their operations to save on costs and to get things done more quickly. But when you're outsourced, you'll be working with those types of customers. You'll be working with other types of customers that maybe are not so standardized or are standardized, but in a different way. And so you can leverage all the experience that we're getting from all parts of the industry and all types of customers just for you that are tailored to what you need today.
Yeah, you're gathering information from a bigger group. So one of the big improvements that we've seen is better software. Is there some software that you're using or that your partners are using that are making your lives easier and reducing costs?
All software is making our lives easier. So we're always developing, innovating our own software internally just to make things move more fluid within the company. But then also, there's tools out there like, for example, Aurora or Helioscope. And what's really interesting about these tools is our customers come to us either to hire us to actually use those tools on their behalf, or that they've used those tools and it becomes our input into the larger, more heavy lifting, full, complete design engineering work. So, it's all these tools have really served one purpose, is to communicate a system more effectively to the audience that needs it. Sometimes it's very technical, sometimes it's very economic, sometimes it's very code and regulatory heavy. It's great that these tools are out here. It's all helping.
So that helps. Now, what's making things more complicated? How are our costs in the industry going up?
Of course, new technologies, new regulations, that always throws things up in a bunch, and having to sort all that out and work with today's policies. Since policy always follows, or regulation always follows technology, it's always important to make sure that we're using whatever tools we have and standards we have today to get projects done today. But then in parallel to that, finding all the gaps that need to be plugged so that we can advocate better policy tomorrow. And that's another thing that we do. For example, I'm actually a co-founder of Green Charge Networks, and we got lithium batteries connected to the grid for demand charge reduction in 2010. Name one code out of the NEC that addresses lithium batteries that was available in 2010. It's barely even available now in 2017, although with the latest code cycle, that is definitely helping. So to get a business like that up and running, to get projects up and running out into the field, you bet we had to take codes out of solar, codes out of 705, and all these other articles to paint a picture that this was a completely code compliant system. That wasn't necessarily cheap to do in the beginning, but you use that experience to then inform what the policies ought to be. and advocate for those at committees and meetings with the CPUC and push them and get them enforced.
Yeah, no, it's really tricky to kind of get that stuff integrated. Okay, Josh, so we kind of started talking about batteries. Now let's kind of dig into battery systems and energy storage systems, especially as they kind of connect together with solar. So what do you think of the current crop of rooftop residential energy storage systems?
Oh boy. So I would say not just the crop of residential storage systems, but all storage systems. I mean, they're largely lithium based, and that's great for energy density and great for footprint. So I can see why residential has a particular interest there. I'm not convinced, though, that lithium technology is the end-all be-all for energy storage, as actually not just with residential, but the industry as a whole. So what do I think about the current crop? I mean, it's new, it's innovative, it's breaking boundaries and breaking barriers into new territories, which is what we all need. And it was available when we needed it, and it was the only available technology at the time that we needed it. So it has served its purpose. It's continuing to serve its purpose, but there's definitely new stuff on the way that's going to completely revolutionize it. So
it's kind of interesting. You've got a perspective on the battery technology. My experience so far over the last, going back 15, 17 years, but now more recently digging into these systems, is the batteries are okay. The battery management systems, they're kind of there, but then integrating it with the electronics, the inverter, the optimizer, the communications, the meter, kind of creating that whole system, that's where right now the industry is kind of letting people down. There's very few systems that are integrated well enough so that you can install them without a lot of custom engineering, custom programming, where you have to kind of go back to the manufacturers. I mean, that's been my experience. So it's been really a challenge, both on the residential side and on the commercial side, to find a system that we can install and that I'm not going to have to worry about going back there every 2 weeks or every month and then finally, throwing up my hands and say, this vendor really delivers. So I don't know if you're seeing any of those experiences also, but that's what we've seen. Yeah.
I mean, lithium as a technology, I agree. One perspective is that there is no problem because it works. It's economic. It's helping people. So why, if it ain't broke, don't fix it. Like, it's fine. It's working. I just happen to believe and have seen there are better things on the way. So the story's only going to get better, I guess. And then,
I was talking to our friend Alex a couple of weeks ago, and he's a big fan of flow batteries. And for commercial, that makes like total sense.
And maybe even for residential, it makes sense. Let's definitely talk about that. But then I totally agree with you on the product configuration, the integration. That I remember, when we were working together at Akina, very once in a while there would be a battery system that would come through. I don't know if you knew about it or wanted to know about it, but they were definitely challenges, always high maintenance. Lead acid batteries, messy, had to fill them with water, and it had to be distilled water. And of course, the customers never put distilled water, so always causing problems, high maintenance. I completely agree. The state of battery technology, or actually battery product configuration and product wrapping, is just come such a long way.
It's that complete product. So what I really like about, for example, we're installing the LG battery. So it comes in a really nice bulletproof, probably really bulletproof aluminum housing. The thing weighs 215 pounds. The battery management system's built in. The instructions are there. It's all compliant with the hazmat regulations, and it's easy to install. There's only a communication cable and 3 wires that you have to wire. So it's like all very simple. The trick is getting the electronics, the meter, the inverter, everything else to kind of operate with that thing very smoothly and updating the software, whatever. So, and it works, but most of the others that I've seen are really, really a challenge.
Yes. And some of them are less, you'll hear different messaging too. Like some of them are more flexible and more, customizable to fit your application. It's like, okay, sometimes flexibility is a good thing. Sometimes it sounds expensive and you're doing more integration.
Well, I would tell you from a solar contractor's standpoint, flexibility usually means that's going to be expensive. Right. All I want to do is install the same thing again and again so I can make it cheap. And the cost is the biggest barrier. How do you think costs are going to come down for these energy storage systems, both for residential and commercial?
It depends maybe on what cost you're talking about, because are we talking about first costs, CapEx, OpEx, total cost of ownership? But from a CapEx perspective, lithium is definitely a winner. It is cheap. It is available for the most part in small quantities right now at the moment. So it's great for now. On a total cost of ownership basis, and also in the context of integrating with solar, I do believe that vanadium flow batteries are the next generation of storage technology that's going to take the industry by storm. And the reason is because it is a true 20-year asset or more. And when you think of solar assets, they need to last 20 years or more, and they can, and they've demonstrated that. To put a battery system that works in concert with that solar system, it's not that it can't be done. It's not that it's not economic today to do so, but it is just so much more simpler and so much cheaper to put a technology with that solar system that has the same design life, if not even faster. Vanadium flow batteries actually degrade slower than a solar panel. It's crazy.
Just give us a real quick explanation of what a flow battery is, how that works.
It is architecturally different in the sense that you have tanks and cell stacks, and those are in two separate places. So your tanks are filled with electrolyte, and that's your energy capacity. You make the tanks bigger, you get more energy. You make the tanks smaller, get less. And then you have cell stacks, which are basically like reversible fuel cells. And they can be bigger or smaller, and you'll get more power or less power. So essentially, flow batteries decouple power from energy, and you can make an application-specific battery that fits your application. When you're buying those lithium batteries from all the big names, you're buying batteries from the consumer electronic industry or from the electric vehicle battery industry, and we're their secondary market. So the batteries that we bring from car manufacturers and put on our house, I mean, those are like 5, 6C batteries. Those are high power batteries that can get your Roadster from 0 to 60 in 2 point whatever seconds. Never going to use that on your house. You will use the energy capacity of that battery on your house for sure, but the power is money down the toilet. So that's still a cost effective today, by the way.
Right. So these flow batteries, there's pumps and fluids and controllers moving the electrolyte back and forth.
Yep, just like a lithium system that has thermal management that moves, fluids and liquids, and also has mechanical HVACs and things like that.
How small can you make a flow battery?
You can make them in fact, there are some. I mean, I'm not saying this is like fully done and wham bam, it's done. But there are flow batteries going into drones right now. Like, people are designing very small flow batteries. They're not commercially ready yet, and there is no residential. There are actually residential flow batteries available in Australia, I believe, but there's none in the U.S. yet. But we're working on that.
Could you put a flow battery behind a solar panel?
Yeah, why not? Yeah.
Cool.
You could. In fact, our friends down the street are doing that, but those are ground mounts or trackers. So
okay. So they've got, right. But what about on a rooftop system? I mean, there's a couple of companies that have that are starting to put batteries behind solar panels. I'm just wondering, how is it going to work in a high temperature environment?
Actually, what's interesting, so that's a really good point. I could see them eventually someday getting behind the solar panel, and how they do in a hot weather environment, much better than lithium. In fact, flow batteries get more efficient when they get hotter, because if you think about the way a flow battery works, it's using some pumps and motors to move fluid around. The hotter it gets, the less viscous that fluid gets. It's a little easier to push and pull. So it actually, batteries, we found, actually get a little more efficient.
The ions are going to be more active inside the fluid.
That's right. Yeah. That's right. The reaction kinetics in the cell stacks move a little more quickly. I mean, the nice thing is it doesn't change that much. It's very stable across the entire state of charge range. So that's a good thing, but it is nice to know that temperature doesn't bring these systems down either.
That's kind of cool. Let's talk a little bit more about SepiSolar. How did you get SepiSolar started? When did it begin?
Oh boy. So it started wanting to help people. I mean, that's as simple as I can make it. I mean, it was, coming out of Akina, and by the way, I mean, was the experience of my life. I will always look back on those years as my golden years, and
here's $20.
I mean, learning from SepiSolar and being Akina taught me how to empower customers, and so starting SepiSolar was really like, I want to take this however I can, and I'm a design engineering expert, and I want to help people. What I found is, what I ended up getting pulled into, though, was every aspect of the project development process. I mean, from pre-sales, from finance to, of course, permitting, utility interconnection, inspection, but then commissioning, and afterwards, for the next 19 and a half or 20 years that system is sitting there, there are things that we don't think about when we think about just installing and moving on. There are things that, you think about when you become the owner of those systems or when you work for an owner of those systems that you just had never thought about previously. So starting SepiSolar was really about helping people getting the experience in the right places throughout that whole project development process, not just up front, but downstream and all throughout.
And how can people get in touch with you at SepiSolar?
They can go to our website, and we have this awesome online web portal at sepisolar.com where you can create a free account and submit quote requests and get pricing from us and get scope of work and get timelines, and it's great. I mean, what's really streamlined our costs and made our system and our business most efficient is communication. I think any licensed marriage and family therapist will say the first thing to go in any long-term relationship is communication. So we've invested heavily in just getting very clear communication up front and throughout the process. We have ways where our customers can interact with our engineers and project managers dynamically throughout the whole development cycle.
So speaking of communication, how do you spell your website?
SepiSolar.
All right. And what's your phone number?
510-940-9750.
All right. Great. Terrific. That's all the time we have on this week's Energy Show. Thanks to our guest, Josh Weiner with SepiSolar. And thanks to all of our listeners for tuning in. If you missed any of today's show, you can always go to our website at cinnamon.energy and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.